Hi everyone, this is our lecture video on section 8.3. In this section, we are using confidence intervals to estimate the population mean when sigma is unknown. In section 8.2, you are introduced to the t-distribution. It's a distribution that's similar in shape to the normal distribution, and it has the following properties. A t-distribution curve is symmetric and bell-shaped, centered about 0. A t-distribution is completely defined by its numbers of degrees of freedom, denoted by df. When we use the t-distribution to create confidence intervals for the population mean, df is equal to n-1, where n is the sample size. The total area under a t-distribution curve equals 1. The x-axis is a horizontal asymptote for a t-distribution curve. So based on the properties alone, the shape of this guy is going to be very, very similar to that of a normal distribution. Your confidence interval limits for the population mean when sigma is unknown is given by the following. Your lower bound for the confidence interval is given by x bar minus the margin of error. Your upper bound is given by x bar plus the margin of error. The margin of error calculation here, since we are using the t-distribution, is based off of a critical value of the t-distribution. That is this t sub alpha over 2. It is a value where the area to the right of that critical value is equal to alpha over 2. And in this picture here, this is a picture of a t-distribution here. The graphing calculator command that we're going to be using for this section 8.3, is t-interval. To access this command, you need to hit the Stat button on your graphing calculator, go to Tests, and scroll on down to t-interval. Let's take a look at the problems. In these problems, we need to construct and interpret each specified confidence interval. Let's start with number 11 from the text. A wildlife conservationist studying grizzly bears in the United States found that the mean weight of 25 adult males was 600 pounds with a standard deviation of 90 pounds. Let's write down what's given to us. The sample size is 25. The sample mean was 600. The standard deviation, little s, was 90. So we need to construct and interpret a 98% confidence interval. So the confidence level for this problem is 0.98. And we're estimating the population mean. And you are not given the population standard deviation. In order to use the t-interval command, one or two hypotheses, rather, at least one of these hypotheses has to be satisfied. Let me scroll back up. So assuming that the sample taken is a simple random sample, and either the sample size is at least 30 or the population distribution is approximately normal, then the confidence interval is given by the following. In this problem, number 11, you are told that the weights of all adult male grizzly bears, they are normally distributed. So we may use the t-interval command. Let me move this screen over here. There we go. So we'll hit the Stat button, go to Tests, scroll on down to t-interval. Now you'll notice that there are two inputs here, right? One says data, one says stats. Okay. The only time that you're going to use the data option is if they give you sample data values. If they give you the summary statistics, such as the sample mean, sample standard deviation, then you need to select the stats option. So we're going to select the stats option for our problem. What's our x bar? Our x bar is 600. What is our little s? Our little s is 90. The sample size is 25. The confidence level for this problem is 0.98. From here, we're going to hit calculate. So there's a rounding rule here that I didn't write in these notes. I will write it in the notes when I upload this to Canvas. So if you're given the summary statistics, we need to round to the same number of decimal places as given in the standard deviation. Your little s was given to be just the whole number 90. So we need to round to the nearest whole number. So our confidence interval limits will be 555. And our upper bound is 645. Bear in mind, in these problems from the textbook, it asked me to construct and interpret each specified confidence interval. So interpreting the confidence interval, let me write down the interpretation here. Whoa, what did I do here? Sorry about that. Okay, we are 98% confident that the population mean weight of all adult male grizzly bears is between 555 pounds and 645 pounds. Alrighty. Okay. Let's take a look at this next problem, number 13. Suppose that you sample 59 high school baseball pitchers in one county and find that they have a mean fastball pitching speed of 80 miles per hour with a standard deviation of 4.98 miles per hour. Okay, so the sample size in this problem is 59. The sample mean is 80. And that sample standard deviation is 4.98. Find a 95% confidence interval for the mean fastball pitching speed of all high school baseball pitchers in the county, and also interpret the interval. So we're going to go to Stat, go to Tests, scroll on down to T interval. We were given the summary statistics for this problem. Let's enter in the givens. The sample mean was 80. The sample standard deviation was 4.98. The sample size was 59. The confidence level was 95%. So 0.95. Okay, what do we have here? So your standard deviation was given to be 2 decimal places. So we need to round our results here to 2 decimal places. So my lower bound for the confidence interval is 78.70. My upper bound is 81.30. Now we need to interpret our result. We are 95% confident that the mean fastball pitching speed of all high school baseball players, all high school baseball pitchers rather, in the county is between 78.70 miles per hour and 81.30 miles per hour. Alrighty, everyone. That is going to wrap up this lecture video. I will see you in the next one.